Hi dear students, we have stopped our discussion over here. That is, we have derived or we have studied how to convert the degree or minute or second into radians, isn't it? So that means for the calculation, whenever we are doing the calculations regarding some angle, so we are not supposed to consider them in degree or seconds or minutes. Okay, if in the question it is given like that, then you have to convert that into the radians, then only you will get the correct answer. Okay, we have discussed about that thing. And 1 degree will be is equal to, we have seen that 1 degree will be is equal to 1.745 into 10 to the power minus 8 10 to the power minus 2 radian. As well, 1 minute will be is equal to 2.91 into 10 to the power minus 4 radian. And the 1 second, that is equal to 4.85 into 10 to the power minus 6 radian. Okay, and as well 1 degree will be is equal to 60 minutes, and 60 minutes will be is equal to 1 minute will be is equal to 60 seconds. That relation also you should remember. As well, if you want to convert degree into radian, you have to multiply that value with pi divided by 180. Okay, that means the value of pi it is 3.14. okay, so now let us come to the next question, that is, a man wishes to estimate the distance of a nearby tower from him. So here is the tower, the man is standing over at this point, that is B, the point B, and AC is the tower. Okay, and spots a very distant object O in a line with AC. Okay, he then walks perpendicular to AC up to B, a distance of 100 100 meters it is, and looks at O and C again. Since O is very distant, the direction BO is practically the same as AO. That means BO will be is equal to AO, but he finds the line of sight of C shifted from the original line of slight by an angle theta degree, that is a 40 degree it is there. Estimate the distance of the tower C from the original position A. Okay, this is the actual question, and you have given with the theta angle the variation in the observation, or the observation angle, the variation it is theta. Okay, and you are having the AB value as 100 meter. You know that if you are considering the tan theta concept, then tan theta will be is equal to, that is tan theta is equal to opposite side, that is AB by then adjacent side, that is AC. Okay, this is AB by AC. Hence, using that AB by AC, you know that AB is already there, so AC value will be is equal to AB by tan theta, that means 100 meter divided by tan theta, where theta it is 40 degree, so tan 40 will be is equal to 0.8391, and the distance or height of the tower it is 100 divided by 0.8391, which is equal to 119 meter. Actually, this is just one of the questions that you have studied in the trigonometric portions in the 10th standard in the mathematics. Okay, the same thing, and we are following this method over here in the parallax method. That's why it is given here to recollect or refresh those concepts. For refreshing those concepts, it is given. Okay, so that is tan theta concept, but here in this case of the parallax method, the theta value is very less, so tan theta will be approximately is equal to the theta only. It's a very less theta value, that means it is represented by d theta. Okay, are you following? Now come to the next question, that is, the moon is observed from two diametrically opposite points A and B on earth. The angle theta subtended at the moon by the two directions of observation is 1 degree 54 minutes. Okay, so if you diagrammatically, if you are explaining that diagrammatically, the A and B points is there. So you are observing moon from A as well you are observing moon from B by using the telescope, and the theta value it is given. The angle theta subtended at the moon due to the observation that arc, it is given that 1 degree 54 minutes where you know that 1 degree it is 60 minute, so 60 minutes plus 54 minutes, so the 1 degree 54 minute will be is equal to 114 minutes. Okay, so that is there. Now you have to convert this 114 minutes into radian. For that, first they have converted that minute value into second, and then it is multiplied with the 4.85 into 10 to the power minus 6 radian. Then so you can obtain the value in radian as 3.32 into 10 to the power minus 2 radian. Okay, and you know that by the parallax theorem, in the parallax theorem, the equation to find out the distance between surface of earth or a planetary object or a celestial object, the d will be is equal to b by theta, where b is the distance between A and B. This distance will be the b, and theta is the angle made by the both lines OA and OB, the observation lines. Then substituting these values in the equation, you can obtain that the distance between earth and moon is as 3.84 into 10 to the power 8 meter. Okay, so regarding that question, example 2.3. now come to 2.4, that is, the sun's angular diameter is measured to be angular diameter. Okay, sun's angular diameter is measured to be 1920 seconds it is. The distance d of the sun from the earth, it is 1496 into 10 to the power 11 meter. What is the diameter of the sun? It is the question. Okay, so that means the entire opposite of the parallax method that we have discussed to find out the length or distance between earth and other planetary objects. Okay, so here we are considering the moon above, and at one point, from a particular point, you are observing the moon by using the telescope. Okay, so this is one of the point and this is one of the point. Let us consider these points are coinciding with the circle. Okay, it is coinciding with the circle. Let us consider like that. Okay, it is coinciding with the circle. So this is the point from in the earth from which you are observing two ends of the diameter of the moon, isn't it? Or sun it is given in the question. So sun. So here A is one of the end of the diameter and B is one of the end of the diameter, and this d distance, this is the distance between earth and the moon. Okay, and we have to find out the diameter of the moon, this distance, that is AB distance you have to find. Okay, AB you have to find, and the angular displacement, the displacement in between the two lines which are joining at the two ends of the diameter of the moon, it is given as 1920 seconds. So first of all you have to convert that into radians. That will be is equal to 9.31 into 10 to the power minus 3 radians it is. Okay, it means 1920 into 4.85 into 10 to the power minus 6. So it will be the, which will be the angle the angular diameter of the sun. So by using this angular diameter value, you have to find out the diameter BA of the sun. So for that, the distance between sun and earth is also given. So this will be the relation, that is small d, that is the diameter of the sun will be is equal to alpha into d, where alpha is this angle, this is the angle, and we have already found that one as 9.31 into 10 to the power minus 3 radian. So multiplying the alpha with the d, that is 9.31 into 10 to the power minus 3 into 1.496 into 10 to the power 11 meter. So you will get the value as 1.39 into 10 to the power 9 meter. That is the AB distance, that is the diameter of the sun. And if you want to find out the radius of the sun, you have to divide this by 2, then you can find the radius of the sun. Exact opposite of the parallax theorem. Actually, in that parallax theorem, we are considering the first two points B and A, and from there earth, one point on the earth you will on the moon you will consider. Likewise you are doing. Actually it was done from the earth, and now in this case, if you want to find out the diameter of the moon, it seems to be observed from 2 points of the earth. One of the point on earth, it is seemed to be observed from the end 2 points on the to edge point on the from the moon. Okay, so that is regarding that one. Now let us come to the next portion, that is estimation of very small distances. Estimation of the very small distances. So now you have seen that for estimating or calculating or measuring the distance between the sun or maybe some celestial object and earth, it is not possible to measure those distance by using the meter scale or whatever the other equipments are there. It is not possible. So the parallax method is there to find the distance between earth and some celestial body. Suppose if you want to find out the radius or the thickness of a needle, some metallic wire, very thin metallic wire. Okay, if you want to find out the thickness of this kind of things, you know that it is lesser than, maybe it will be lesser than the 1 mm value. So it is not possible to measure it with the centimeter scale or meter scale. So I think I have already explained to you about this thing, that is the screw gauges and vernier calipers. The screw gauges and vernier calipers are used for that purpose, to measure the distance lesser than 1 mm. Okay, so the screw gauge, for the screw gauge, the least amount measure can be measured by the screw gauge, that is the least count. It is known as least count, that is the least amount which can be measured by that device. That is actually is equal to 0.001 centimeter. Otherwise we can say 0.01 millimeter. That is the smallest distance can be measured by screw gauge. As well for the vernier caliper, it is 0.01 centimeter for vernier caliper. That is the least count of vernier caliper. So which can measure lesser than the 1 mm distance also. Screw gauge is usually using for measuring the radius of thin wires, as well the radius of some other very thin light or needles. For all those purposes we are using the screw gauges. And suppose if you want to find out the structure in an atom, or suppose you are in biology practicals or biology, you will study to use the microscope, optical microscope, to observe the plant cells, animal cells, blood cells as well. Those things, for those things you will be using the optical microscopes. As well, for measuring 2 times magnified images that we are observing in the optical microscopes, we can by using the electron microscope, you can magnify them double the time. Okay, So regarding that electron microscope, actually we have discussed that electron is having a wave like a nature, a wave structure it is there for the electrons. So by taking the advantage of the wave nature of the electron, we are using the electron microscope. We will allow the electron waves to fall on one body, and from the pattern of the reflected wave we will study the nature of that object. So for measuring the very small distances, the two units that are, first is Fermi and another one is angstrom. One Fermi it is actually 10 to the power minus 15 meter, and one angstrom is 10 to the power minus 10 meter. As well, if you are going for the larger distances, it can be measured in astronomical unit as well, light year and parsec. The astronomical unit is actually 1 AU. It is represented by 1 AU. Average distance of sun from the earth, average distance between the sun and earth, it is 1 AU, and which will be is equal to 1.496 into 10 to the power 11 meter. That is the that is SI unit. One astronomical unit, 1 AU is SI unit. It can be obtained as 1.496 into 10 to the power 11 meter. As well, another one of the unit of length, actually this unit is using for measuring or defining the distance between the sun and earth, or maybe between that much far distances. To measure that much far distances, the astronomical unit as well the light year is using. One light year is actually 9.46 into 10 to the power 15 meter. Actually it is the distance of the light travel with velocity of 3 into 10 to the power 8 meter per second in 1 year. That is why it is known as one. That's why it is known as the 1 light year. It is the distance traveled by light in 1 year. You know that which is the fastest object in earth or in universe, that is light. Actually it is 3 into 10 to the power 8 meter per second. If actually as per the scientist hypothesis, suppose if one object can obtain the velocity of light, then it will be having the ability to do the time travel. The scientists are hypothesizing like this. It is not scientifically proven. Okay, that means for anybody it is not it is very difficult to obtain the light the velocity of light for some physical bodies. Okay, and another one of the unit to measure the large distances, it is parsec. That is actually 3.08 into 10 to the power 16 meter. Actually the parsec is the distance at which average radius of Earth's orbit subtended an angle of 1 arc second. If the arc second, it is 1 arc second only, then that is the Earth orbit distance between the average of radius of the Earth's orbit. That is 3.08 into 10 to the power 16 meter, 1 parsec. So light year, astronomical unit and parsec are some of the units which are using to measure larger or far distances or larger lengths. Okay then, thank you for listening the class. You just go through the textbooks and exercises also. Okay, you just go through the exercise portion, and if you can do some of the exercises, you just try to solve that one. Okay.